Welcome back to FinMatrix Insider. Today we're diving deep into the fascinating world of artificial intelligence, specifically the logic underpinning AI that actually does things. We're talking about the fundamental building blocks, the algorithms and architectures that allow AI to execute tasks, from simple automations to complex financial modeling. This is crucial to understanding both the power and the limitations of these tools. The first and arguably most critical step is problem framing. Before any AI can tackle a task, it needs to understand exactly what the task is. This isn't as simple as just telling it, balance my budget. Instead, we need to translate the real-world problem into a language the AI can understand, numerical data and mathematical relationships. Problem framing is the blueprint stage for AI. It involves defining the objective, identifying the necessary input data like market prices, and establishing constraints such as regulations or budget restrictions. Once the problem is framed, we need the engine to solve it. This is where algorithms and architectures come into play. These are the sets of instructions that guide the AI's decision-making process. The choice depends heavily on the task, ranging from decision trees for classification to neural networks for complex pattern recognition. Let's zoom in on neural networks, which are increasingly dominating many AI applications. They are excellent for complex pattern recognition, making them ideal for forecasting. A neural network learns through a process called training. This is how the AI becomes effective at its task. Neural networks consist of interconnected neurons organized in layers. Each connection has an adjustable weight, which represents its importance in processing the data. Data enters the network, gets processed, and produces an output. The key is training. The network learns by adjusting the weights based on feedback, essentially learning from its mistakes to become more accurate. Algorithms are only as good as the data they receive. This brings us to feature engineering and data preparation, often the most time-consuming part of the process. This involves cleaning the data, removing errors, missing values, and inconsistencies, much like preparing raw materials before building a product. We also perform data transformation to convert information into a format suitable for the algorithm and select the most relevant features to focus the AI's attention. With the problem framed, the algorithm chosen, and the data prepared, we finally get to training and validation. This is where the AI actually learns. The data set is split. Training data is used to teach the AI, while validation data is used to evaluate its performance on data it has never seen before, ensuring reliability. We use key evaluation metrics, such as accuracy and mean squared error, to rigorously measure the AI's effectiveness and reliability depending on the specific task. Once validated, the AI is deployed and requires constant iteration. This involves monitoring its performance, gathering real-world feedback, and continuously retraining the model with new data as needed. Understanding these core principles is crucial for navigating the evolving landscape of AI in finance and beyond. Expect continued sophisticated algorithms and seamless integration into our daily lives.